Everyone. Welcome. Thank you very much for attending this webinar. So this talk will be about AI coding agents. I'm Frederico Vicente. I'm the co-founder and the head of AI of Dypsis.ai. Before we dive into this topic, just some small notes. So this will take about 1 hour. This will be recorded, so you can also check the webinar on YouTube afterwards. There will be a Q&A panel, so you can ask some questions. And in the end, we will answer those questions, and you can even ask some questions at the time. So yeah, let's start this webinar. So what are we going to talk about today? So firstly, we are going to talk about integrated development environments, and now AI is currently already present in this development environment. So we're going to talk also about agents. We are going to introduce what agents are and coding agents. Then we will talk about Cloud Code, which is a very good example of a coding agent system, and currently one of the best. We are going to talk about some common workflows where these coding agents help us a lot. And then we are going to talk about some best practices to take advantage of these coding agents to our gain. And in the end, we are also going to talk about the current trends, future trends, and takeaways I think they are important about these coding agents. Lastly, we're going to just mention some services that we offer at Dypsis.ai that might help you in some ways. So to sum up this talk, so currently the world is changing a lot. Programming is almost every day with the new tools, new AI tools. And I think it's safe to say that currently choosing a development path without AI tools, is a wrong step. So I encourage you to, if you're not already using some level of AI productivity apps or AI tools such as Cloud Code, I really suggest you to do so. And I would like you to think about 6 months out, so to think about into the future, and to really think how, if you start already at the moment using these tools, how productive you might be looking 6 months. So and let's now dive into IDEs, so into integrated development environments. So in the past more or less 40 years, they have evolved quite a bit. So from terminal-based interfaces to very rich and with high features development environments. So even nowadays, we start seeing some agentic development environments like Cursor and Devin. So, and the idea of IDEs is really to augment our productivity, and so to deliver features and to products much faster than in previous times. So, and the idea of these new IDEs and agentic development environments that are coming in is also to really augment our productivity. And so at first, when, let's say, intelligence, when it started appearing in these IDEs, it was more related with autocomplete. So you would start writing some line of code, this function, and it would suggest some piece of code that would make sense in that context. It was not great. Then afterwards, these agentic development environments started appearing, like Devin, Cursor, and nowadays there are much more. Today, really, there are two kind of paradigms that I wanted to talk about. So we have this more terminal-based agentic coding systems, which, for example, Cloud Code belongs to this family, where the focus is more on the models themselves and the agentic patterns that the developers think work best to augment the productivity of developers. And then we have, and the benefit of having these terminal systems is that you can integrate them into any type of environment that you're already working. So, for example, you can work in JetBrains IDE, and because, for example, Cloud Code works in the terminal, you can just plug in and start using it without breaking your patterns and your with the work you used to do. So, and then you have this other paradigm, which is IDEs, these new agentic development environments where basically the people are developers are developing new family of IDEs with agentic native features. For example, you have Cursor, Windsurf, Warp, Devin, but in this way you have to change the way you work, because you have to let's say get used to how these new development environments work. So they both have their advantages and disadvantages. It's up to you to really see what works best for you. The key takeaway is that the development experience is really changing a lot, and it will continue to change a lot in the following future. So get used to it, start to playing with these tools that already exist, and see what works best for you. And before continuing, I think it's important to meditate a little bit about the type of users that use AI, and to what kind of user you yourself you see yourself in this situation. So, for example, normally when users start using AI, usually they are basic users, so they start just chatting. Maybe you ask the for example, you go to ChatGPT and you request for help to write an email, or you give a document and you ask for a summary of that document, for instance. Then you have this pattern, which is when users start getting more comfortable and start exploring the overall features of these systems. Like you start maybe creating some custom agents that the system allows. You start to creating projects with predefined documents. You even start maybe connecting some MCPs, some tooling to get the most of these systems. And lastly, you have like this new, let's say, way to interact with these agents, let's say, which is using real coding agents, where you have like cloud codes. For example, recently Google announced anti-gravity. You have the Warp, Cursor, and here you can write codes. You can manipulate and have access and the file system, and you can do a lot of automations if you want. If you know all the capabilities of these systems. And most of the users get stuck at most at the second one, but actually I argue that if normal people would have some fundamentals of development, and they could get the most of the capabilities of the third kind of user, because currently coding agents are not only for developers. They offer some really good, powerful capabilities that normal people would really benefit from. So now we are going to start a poll, and so just to get to know a little bit of you. So what kind of user do you see yourself in? So 1, 2, 3. What kind of user do you feel like you are? Okay, I see. I see that most of you consider yourself basic users. Okay, really nice. So I think this talk will be interesting for you. Okay, so I'm gonna move forward and start talking about start talking about agents. So normally people confuse the concept of large language models and with the concept of agents. Of course, when people are talking, maybe it's easier to call everything agents, but they really are different things. So we can think of a large language model as a complex function that for instance, you give it some text and it outputs some kind of output text as well. But it's only really considered an agent when there is some kind of you can even, for example, in the LLM, you can even give it some tooling, so you can give it some access to the web, but it only starts really being an agent when you have some type of environment, some type of reasoning, and there are some iterations. So a user asks, for example, questions, or it has some requests, and the agent doesn't only give an answer, but it in a sense it starts iterating to understand if it has the enough information, for instance, to provide an answer. It reasons about it, and maybe it manipulates the environment itself. So if, for example, it checks some files, it goes to the internet. So it's a more complex. It plans what it needs to do. So it's a little bit more complex than just providing an answer. So what I want you to take away from this is that there is really a difference between a simple LLM, let's say, and an agent. And currently, I think you can categorize, let's say, agents into two families. So you have like this empowering agents and autonomous agents. So in the empowering agents is more or less like the example I gave you previously, which is like you go to ChatGPT, for example, and you ask to summarize an email, or you ask it to help you write an email. So in a sense, it's just giving you, for example, helping you in a task by reducing the time it would take you to do that task. When we talk about autonomous agents, it's more like we have an independent system which is already integrated in some kind of process, and it is already taking advantage of some type of integrations that you have, and it executes by itself when something some action triggers it. For example, imagine you have some type of agent integrated with your CRM, and you have set some goals to achieve some revenue by the year, and you are a little bit off, and it starts doing some calls, or it starts suggesting you to call some clients to achieve that revenue that you need, that you have set, for example. So they are different, but we take the most of these systems when we use both, because both are really powerful. Also, an important aspect about LLMs, which in the sense are the fuel of these agents. So most people, I think, kind of forget this, but it's very important to know that LLMs are only trained up to some dates. So the information that they have is limited to a certain date. For instance, even the most recent ones, GPT-5s, for example, are trained up to the data information from 2024. So you shouldn't expect it to really be able to answer your questions, and you shouldn't trust them as much in information that you expect it to be up to date. So if you need to reason about information that is happening, for example, in this year, or something that happened recently, you have yourself to provide that context, that information for it to really reason and be helpful for that. Okay. And what kind of orchestration patterns are normally used with these types of agents? So you have the more simple one, which is the sequential one, where an agent is specialized, for example, in the task. Let's say it does that task. You give it some input. It performs that task. Then it passes the output to another agent that is specialized on performing that task, and and agent 3 then uses the output of agent 2 and provides you the output. You have also the hierarchical one, which you have like an orchestrator, a main agent, and then you delegate some, you can parallelize and you delegate some tasks to, for instance, subagent 1, 2, and 3. Then you have like this collaborative environment where each agent has it's more or less independent, but they collaborate with other agents to solve some certain task. You have also this pattern, which is scatter and gather, where you have an agent and then you distribute, let's say, the compute to other agents, and then you collapse the output to continue some request you have or some task you need to solve. Then you have the orchestration loop and workers, where you have this main agent. You delegate or you ask for information from another agent or an external system, and then you wait for that information to pursue the execution. Now, according to the autonomy, so for example, in coding agents, let's use that example. So, like I was previously saying, you can follow like a copilot mode where so you can even ask some suggestions, and the agent provides you should write this code, but then you have to approve, and maybe you even are using like something like ChatGPT, and you are copying the code and then pasting it. Then you have like this more advanced, which is supervised, where you kind of let him already start doing some actions, but you will always approve every action that he performs. Then you have a more autonomy level, which is the task level, where you have already maybe planned what tasks the agent should do, and you let him start applying those changes on the fly, and you only review, for instance, for each task. And then you have, let's say, a YOLO mode, which is you basically give almost all control to these agents, and you just maybe waste time planning things, and then you let him do a lot of changes, and you just review things after after several tasks have been made, for instance. And yeah, now let's start talking more precisely about a specific coding agent. So I'm going to focus mostly on cloud code, but today there are a lot of the agent codes. For instance, you have Codex, you have Gemini CLI, you have a lot of these kind of systems. I really like cloud code. That's why we are focusing a little bit about this. But in the end, most of the things that I'm going to talk, they are general to all these kind of systems, because they all more or less follow some patterns that all follow. And so to start a little bit more, talk about more about cloud code. So it's in its essence, it's a terminal-based app, which is a coding agent, and you interact it via the terminal. So in a sense, you can think of it like a ChatGPT, where you can have conversations, but it's always via the terminal. What does it have under the hood? So as I was telling you, it's a terminal. You can also access it via the via CLI commands. You use it via natural language, and it is able to plan, to reason, help you in decision making. It's really good at managing context, and it brings you with a lot of functionalities that make it great. So it comes with built-in tools. So it allows you to manipulate, if you give access to manipulate the file system. It can read files, it can write files, it can edit files. It has integrations with Git, and you can add external functionalities like MCP servers. You can add skills, which is a recent functionality that we are also going to talk about. You can have hooks, commands, subagents, and you can configure it to follow the patterns that you prefer. So there is a special file, which is cloud.md. On other coding agents, normally it's called agents.md. And the idea here is to customize the behavior of the coding agent and to provide some overall details about the project, some patterns that you, when you are programming, for instance, that you would like to follow. And so there are a lot of things that you can customize, like permissions, which commands do you allow to execute automatically, which ones you need to have an opinion about. Like imagine that you don't like for Cloud to use the bash command of remove, for instance. You can change the permissions, or to always ask you permission to delete a file, for instance. So you have some admin control, let's say, of how these agents behave. To make it easier, for instance, for developers that already use IDEs, they also offer a lot of integrations with IDEs. For instance, there are some plugins that you can add to VS Code, to JetBrains, the most popular IDEs. So you can, for instance, when Cloud suggests a change or when changes a file, you can see it like as if you were looking at Git changes. So you can see exactly what the changes were. So it facilitates it starts building trust. For instance, for people that start using these systems, it starts providing some comfort whether you like the result or not about the changes that these agents perform. So this is a new example that, for instance, this is in the JetBrains IDE. So you go to the plugins and you can download, you can install the Cloud Code plugin, for instance, to have access to it. So now I'm going to talk more deeply about these functionalities that, for instance, Cloud Code brings to the table. So as I was saying, it provides you file system operations, so it can read, write, create or delete files. It can execute code. So if you have CLI apps, it can run those CLI apps. It can run bash commands. It works really well with Git. It knows how to use Git, so that's really helpful. It knows how to search for patterns within files, so it is very smart when finding something that needs to find on your file system. It has some web search tooling, so you can search the web. Of course, you can also add some other subsystems, let's say, to help you reach other external services. It also has some user interaction utilities. For instance, when you are making plans, it often asks you questions to make sure that it has the full picture when developing a feature. Then you have also this utility, which is very powerful, which is commands. In a sense, it's a way for you to follow best practices to write some predefined files of prompts, where you, for example, if you repeat yourself a lot, so for example, every time you do a feature, you would like to create some documentation, you can, for instance, write a command. You can on a specific folder, you can put a prompt there, which describes how you'd like some documentation to be created every time you develop a feature, for instance. And then in the terminal, you just have to write /docs, for instance, if you name it docs, and the agent starts creating some documentation for you. So this is a way to don't repeat yourself and to have some predefined files to execute commands on the fly. Then there is also this feature, which is subagents. So normally it's used to create some developer personas. So you can have subagents specialized, for instance, in front-end or back-end testing. It's great. They are built especially for this idea to have clean context separation, because normally in the end, when you are interacting with Cloud Code, it's a conversation, like in ChatGPT. You are having a conversation, but the goal normally is to to create some feature or to develop some code. But in the end, it's a conversation with a lot of iterations, with a lot of, and the idea of subagents is that they execute in a separate context. So and that allows you for your window of conversation to be much cleaner. And also a very good thing about subagents is that you can run them in parallel. So for instance, Cloud Code by default, when you want to explore the repo, the repository, or your code base, it delegates some workers in parallel to explore the code repository, and then that information is collapsed. So it's a way to also spare some time to now about the MCPs, which is a concept that maybe you're already familiar with. It's also a feature that is very rich, and it's available in almost any AI-related tooling these days. What is the goal here? So before MCPs, so when people wanted to integrate their, let's say, AI systems with external services, they had to create custom logic and to interact with these external systems, and it was not great. So MCP is a protocol that's now currently is a standard, and now what happens is that we have some clients, which, for instance, Cloud Code would be considered a client, or we have like ChatGPT or Cloud Desktop, which are considered clients. And then these providers, for instance, imagine Google Drive or Slack or GitHub, they would create a server to provide some tooling which LLMs are much better, know how to handle them much better. So this, in a way, now, because of the MCPs, it's much easier to integrate with external services. You can even create your own MCPs service, which can run locally to have some special logic that you want. And so they provide a really powerful way to interact with these external systems. So APIs with the databases and custom logics that you want. So for instance, there are some very good examples more related with coding. For instance, we have Context 7 and Ref. For instance, it's very nice when, for instance, developers usually are faced with this issue or problem that libraries, SDKs change a lot. And as I told you in the previous slide, LLMs knowledge is cut off like 1 year before. So using these tools, it's great because it helps you have up-to-date documentation. So if you set up these MCPs, and you ask to, for instance, access a specific library, you always have access to the most recent or to a specific version of the library that you want, which helps a lot to reduce the possibility of hallucination from the LLMs. Also, also very powerful feature that was presented like 1 month ago, more or less, which is skills. This is very interesting because it provides some capabilities to the agent that it doesn't have by default. So, for instance, this is an example that Cloud Code gives, which, for instance, is a skill to read files and even to fill some fields on a PDF if you need. So, in essence, it's every skill you provide an instruction, like for instance, here is skill.md, where you provide, for instance, the description of how this skill works, and it can even execute code. So you can put executable code within these skills, and that's what makes it really powerful. And the difference between these, for instance, and commands is that commands are executed manually, while if you have a skill, Cloud Code will execute it dynamically. So if you feels like the skills can help answer a specific task or help it to fulfill a task, it will call this skill automatically. So this is really powerful. For instance, at our company, for instance, we have created some skills, for instance, to to create proposals for some clients. So we have our branding, we have defined our branding, and we create PowerPoints, and we even ship it to Google Slides automatically by using this feature. So as you can see, Cloud Code is much more powerful, not only for developers, but as a really a general agent that can help you really automate some tasks, and so it's really powerful. This skills is very interesting for some tasks. I also provide here some examples. For instance, to manipulate and create the docx files, PDFs, PowerPoints, Excel files. You can even have a skill to create other skills, for instance. So these are just some ideas. The main idea that I want you to take is that these skills are semantically triggered and dynamically triggered by the agent itself. Another more advanced tooling that Cloud Code has is this idea of hooks. So it has some predefined events that it is always listening to. So for instance, when the agent is thinking of using some tool, like for instance, read a file or edit a file, you can have some custom scripts that every time it does that, it can trigger some script that you have to do some. You want to do some logging for audition. To audit the usage. Or imagine that you want to compact the conversation and you want to store that information in the .md file. For instance, you can have a script to do that, for instance. So it's very powerful, more for advanced users, let's say, but it can provide with a lot of utilities that are powerful. Now, I also wanted to talk a little bit about context because it's really important, especially if you are on more simple plans. So if you have normally using Cloud Code, you have to pay for some plan, right? So if you just are paying for the Pro, which is more or less $20 or something, you have more reduced amount of tokens that you can use for the usage. So you have to be a little bit smart about how to handle this context that you have, for instance. And so I wanted to be very clear about what goes into the context of these conversations and how you can optimize it in some way. So not all conversations have this kind of structure. So you have the system prompt, which is let's say a prompt that guides the model itself. So it's in this case of Cloud Code, Anthropic decides what instructions it gives to the model for it to behave in the agentic way that we know. Then it also provides some system toolings which is related to those built-in tools that I was mentioning. So it informs the agents about the tools that it has access to, for instance, to read files, to edit files, and so on. And then it also provides MCP tools information so if you want to have access to those MCP tools that I was mentioning before, for instance, to connect to GitHub or to Jira, whatever, you have yourself to customize that to use those MCPs. But once you do, on your conversations, that information always goes into the conversation. Also, you have the memory files. So in the beginning, I mentioned to you about this cloud.md file or agents.md file. Normally, this is what is considered a memory file. It always goes into this conversation. So you have to be a little smart about the information that you put in, because if you put a lot of information, not only the agent starts ignoring it, but also because it always puts it in the beginning of the conversation, but also it can take a lot of information in the conversation, and you don't want that. And then you have the messages, which is your questions, your requests, and the answers from the agent itself. So to really be able to manage this context in an intelligent way, there is this concept of context engineering, which is in the sense is about really to think about what's relevant to put in the context. So what kind of history you want to provide, the memory files that I was mentioning, what is the structure of your own prompts, of your own questions. For instance, it's very good for you to always be very precise about what you want, and this is the output of the and to really instruct about what you expect the output of the agent to be. So this is the idea of structure output. So there is a lot to think about when you are interacting with these systems. And the most important strategies is really to provide information that is correct, complete. You should always strive for efficiency in the information that you have in the window. So you don't want to have a lot of information because you can confuse the system. And you always want to be very clear about the trajectory. So to follow a specific goal that you have. For instance, imagine you have an issue in your codes, or you have a bug, and you just say fix my bug or wherever. It's very vague. So the trajectory that it will follow will be very hard to follow for the agent, because in your system you can have a lot of bugs. So if you precisely say what you need and what you want, it can follow your goal much better. On the left side of this slide, I have just this representation of a conversation. You will see it in more slides, so I just want you to have an idea. So as I was telling you, these conversations always have these system instructions from the model. The cloud.md, which is the memory file that all projects normally have. You have the built-in tools, the MCP. Then you have an iteration of user messages and assistant messages. So now I'm going to talk about common workflows that normally normal people follow when using these systems. So it's very important when you are using these agents to make thoughtful plans. So you should really strive to spend a lot of time on this concept of PRDs, product requirements documents. So you should spend time really thinking about the specifications of what you want to build, and provide clear guidelines and the libraries, dependencies that you need. Because currently these agents are really good at executing, at producing code, but they are only as good as the plans that you create and the specifications that you provide. So you really should meditate a little bit and really spend some time here, because the output will depend on these plans that you make. So be careful to specify all the things that you are aware that should appear in the code that will be created. For instance, provide out of scope, for instance, files that should not be changed. Specify some edge cases. You can even iterate with the agent itself to, for instance, provide you some ideas of edge cases that you are not thinking about. You should ask for what tests to be created. So the more complete these plans are, the more professional code will be created. So this is really a paradigm that people normally follow, this workflow, which is which has these three phases, which is the exploration, the planning, and the implementation itself. So on exploration, you have this first phase where you want to build a feature, for instance, but you first need to have you want the system to have a real understanding of the code base, of what current for instance Git issues that exist, or what Jira tickets that you already have. And so this is the exploration phase, where the agent starts collecting information and knowledge to really provide you some accurate answers. Then you should follow to this planning, where it's related to the slide that I previously showed you, that once the agent has a good understanding of the code base, and then it can provide you a very precise and related to the specifications that you provided, it can create you some a very deep dive plan of what to build. And then once this plan is created, then you can move to this implementation. That if the plan is very profound, the code should normally the output should be more or less accurate. Of course, this is not magic, and you always have to test and verify things. But if the plan is well made, the code should also always follow this the patterns of the plan. And so, in a visualized way, this is more or less some common workflow that people normally follow. So you have this research. You can, for instance, create a command, for instance, called research codebase, for instance, where it follows your rules to really make a powerful, let's say, exploration through your codebase. Then you can also suggest it to create a research.md file. This is very important, as I'm mentioning here, for you a human to review, because it's very important for this to be right. So when you start planning, the agent really has the correct understanding of the code base. So it's very important to review this. When you do the planning, you can also output plan.md or a collection of phases.md, for instance. And it's very important also to review this, because if you don't review this, and if the agent assumes things that are not correct, the implementation will most certainly also not be right. So, and this brings me to this slide, which is one line of code is one line of code. But if one line of research wrong or one line of planning that are wrong, it can produce a lot of code that is wrong. So you have to be careful with this approach to really guarantee that the understanding of the code base is correct and the plan makes sense according to what you want to build, so as to avoid having code that is produced and it's wrong and it doesn't solve your problem or doesn't actually provide you the feature that you wanted. Also, so for instance, test-driven development is a common methodology. So you can bring methodologies that you always have worked with and apply this, let's say, AI tools with this. So you can, for instance, do the planning as normally you do, but instead of start writing code, you can start by writing tests, and so following this methodology of test-driven development and iterate with the agents to really achieve this. So in a sense, these AI agents, coding agents, really are here to help us and not really to reinvent the wheel. So if you follow these methodologies, it's just a matter of adapting to these AI systems. There is also this common workflow, which is visual iteration. So, for instance, if you are building some UI, by using these AI agents, it can be a little bit easier to debug these UIs. You can use, for instance, some tooling like Puppeteer and Playwright, and you can have the agent itself iterate with what it is creating and have a visual understanding of the results. You can also, with Cloud Code, you can even, for instance, if you want yourself to debug the visuals, you can provide screenshots to the agent and provide some alterations, modifications that you want to the UI. So it's very powerful features that you can follow. So now I'm going to provide you some best practices when dealing with these coding agents. So firstly, I think it's very important for teams that are using these coding agents to really spend time in configuration, because it's in these configurations that you, if you spend some time, all your team can benefit from this, because these are patterns that you can apply all your repos, to all your teammates. All your teammates can suggest and reuse these patterns. So you can normally using Cloud Codes, you can create this folder which is .cloud if it's not created automatically, and within this folder you can create several features which are related to those features that I mentioned in the beginning. So you can have subagents in the agents folder, where you can specify several markdown files which define how each subagent is supposed to work. You can also create a commands folder where you can put a lot of markdowns with those predefined prompts that you would like, and these commands can be more or less complicated depending on your likings. So these commands can accept parameters. They can, within themselves, the prompts can someone can call the subagents. So the prompts in commands are really powerful as long as you know how to use them. You can even add some skills, so you can specify them in the skills folder. For instance, here I have an example of where we created a skill, for instance, to generate content for social media, for instance. So, as long as you are creative, skills can help you with a lot of tasks, and they are basically special domain capabilities that you can add to Claude. And because you can have executable code running on them, and they are dynamically called by the agents, they can be really powerful. And this is how you can add some skills. So you create a folder skills, and you add some subfolders with the specifications of how the skills work. You also have this settings.local JSON, for instance, where you can also add MCPs, or you can also add them via CLI, so it's up to you. And as I was mentioning before, so the idea of the MCPs is really to also provide some external capabilities to the agent. So you can have you can add some capabilities to connect with Linear or with Jira to always be aware of some tickets that you have, some epics that you want to follow. You can also add some external tooling to access documentation, web browser, Google Drive. So there are a lot of external capabilities that you can add to the agents. And you can add them via MCPs, or you can inform in CloudMD, for instance, about CLI tools that you have. So because normally CLI tools actually work better than MCPs. So if you have some local tooling on your computer, you should actually use them instead of MCP, because they normally will work better. But when connecting with external systems, normally MCPs might provide some better way to access them. So also talking a bit about the common approach that normally people follow, which sometimes fail. So sometimes people start having some conversation with the agent to perform some to create some feature, but sometimes it starts behaving badly or creating some bad code, and people start to do this instead of that, and what happens here is that you start having conflicted context information within your window, and that really makes the agent start working worse. So the idea here is, when that starts happening, you have some options that you can have. So you can, in Cloud Code, for instance, if you press 2 times in the escape, you can go back in time. That's a feature. Also, you should always use Git when developing. So you should maybe create a branch, start doing some commits, so you can easily also revert what you're doing. And you can also follow this approach, which is to when you are advancing, so you're having conversation with the agent, you can compact frequently, or create a new session, so you also have like a clean context window. And you can also have like this progress.md, for instance, where you keep track of what is done, or what features have already finished or not. So depending how you plan the features, you can be really smart about the information that you pass into the agent. And you should really give good use of subagents. So as I told you, they are a good way to parallelize tasks and to have context to manage context well, because as I told you, subagents work with their own context, and they can be called in a parallelized way. So, for instance, if you imagine that you want to, for instance, read some part of the repo that you have, you can, or you want to search the web, you can actually ask Cloud Code to create some workers to search information on the web, like 5 workers, and it starts searching. It creates like 5 sub workers to go fetch information, and then it fetches that information and provides it to the main agent. So if you use correctly, subagents is really powerful. So it should follow this flow that I mentioned previously of exploration, planning, and code. It provides you really good results. How should we structure these plans? So normally what I do, and what I think people do, is they create this document, which is for instance, I'm going to call it like agent docs, or you can call it differently, where you put the plans, the features that you want to make. And when you are in planning mode, you start really phase by phase creating this markdown documentation about the specifications, about the success criteria, the libraries that you are going to use, and so on. And you should also have like this progress.md to really keep track of what the agent has already done, and not to reduce the possibility of hallucination and conflict in information. So, and it can be as complex as this, as I'm showing you here, or it can be a little bit simpler. So you can have just a plan name folder, and the full plan. You can have the full plan just to always have a overall idea of which feature you are building, and then just have a file for each phase with following the same ideas that we were talking, and have a progress to the agent always know which phase is already being covered or not. And following best practices, if already you are working with Jira or Linear, if you can have some MCP connection with these services to always, for both systems, the agent and the tickets on Jira or Linear, always be so up to date, and the visibility of the system is known by all the people on your team, and even documentations and so on always be up to date, and so this is the way you actually can get the most of these systems. And what goes within each phase, markdown. So as we were talking about PRDs, so it should have like the objectives, the specific tasks that can map one-to-one to the Jira tickets. Each phase can be an epoch, or I mean, you can design this the best way you prefer. So it should have success criteria, so for the system to have an idea of when it should finish a phase or not. And it's very important to really be clear about the prompts that you provide to this agent. Like we were mentioning previously, if you just say fix the bug, it's very vague, and the system can go in multiple directions. So if you really provide the specific logs or errors, it will try to fix the issue very precisely, and you will get the best results following that patterns. And now, to conclude, so currently there are a lot of trends that are being pursued on this AI ecosystem, let's say. I think that we will start seeing even more good capabilities on local LLMs. So I think local and edge AI will start gaining a lot of track. We will agentic IDEs for me. I mean, we are already seeing them exploding in the popularity, and this is the why also we are having this webinar. So they are really going to change the, let's say, how we create software, and they will start having even more AI native features, let's say. So even in debugging maybe, and even other features that normally IDE have, I believe that they are going to be more feature rich with AI capabilities. I also believe the MCP ecosystem will continue to evolve a lot. For instance, recently there has been some updates to the protocol, for instance, to provide the UIs natively. So for instance, within ChatGPT or Cloud Desktop, we soon might start seeing some UI widgets within those systems, which will provide people that are not very, which have developer, let's say, knowledge, to start having more ways to interact with these systems, and that will be very interesting. And yeah, all the other things on this table also are going to keep growing. So if you haven't used Cloud Code or an agentic system before, I think you can start, for instance, by installing Cloud Code. You can start, for instance, if you are a developer and you have a repo or you have a personal project, you can start with the simple tasks, maybe writing some tests, fixing a bug, adding a small feature, at least to start gaining some confidence in the quality of the system. Always create a cloud.md file, because the cloud.md file will always be provided to the conversations, and it can help the agent have a better understanding of the code base and your standards of your patterns of development, and so it's very powerful. If you require, and even for curiosity, you should start adding some MCP servers if you feel like they are needed. For instance, add MCP servers for accessing documentation up to date, or other tooling that you might feel like it's important. And yeah, and start measuring if it's really helping you or not, if it's providing you some good utilities. Yeah, so I think this is our good tips. What are the current limitations of these systems? So, for instance, for problems that have not been solved yet, they are not perfect. So these systems are not magic. So they have been trained on a lot of code, a lot of information on the internet, and so they work best on things that have already been on problems that already been solved in some way. So for very state of the art, let's say, things maybe they won't help you a lot. So they can still hallucinate a lot. That's why it's important to really guide them to follow your what you want and the context that you can provide. For instance, business context understanding, it's something that humans can provide. So the system will not know things about the domain of your problem if you don't tell him, because each domain is very specific. So you have to be careful with these limitations and try to really help the agents to overcome in some way these problems. So you gotta be a little bit intelligent to overcome this. So the key takeaways that I want you to take from this is that yeah, so coding agents are becoming a big deal. So if before we were seeing it just as systems, now they can really become autonomous developers as long as you are careful with planning, and you spend more time on the planning side and reviewing what they are about to do. They can really become autonomous in some way. You should use MCPs to help you integrate with external systems. It will provide you a lot of interesting tooling. Configuration is really the key. So really spend time configuring this to be powerful, because as I mentioned, these systems have a lot of capabilities that can really provide you with great power. And if it's the first time you are using this, start small, measure the impact that it's taking, and gradually start doing more complex features, more complex following more complex patterns, and you will see that how powerful these systems can be. And yeah, the future is human agent collaboration. So don't think this as a replacement, but really it's really empowering how much we can do in less time. So it's very powerful, these coding agents. So yeah, so now just introducing a little bit about our services. So Dypsis.ai, in Dypsis.ai we focus on these 4 services offerings, which is in AI strategy and consulting. Then we also provide the services of helping companies build some AI pilots, and we also in this third thing, which we help companies actually build things with AI, with machine learning, and really trying to help some processes by integrating some AI methodologies. And finally, like this webinar, we provide services for training to help companies be better informed about some AI methodologies, machine learning capabilities that they could be applying to their businesses. So here I am presenting, for instance, the courses that we offer at the moment. So we have a deep dive on coding agents. So in this hour, we were limited to the amount of information that I could provide you, but we have a more deep dive about coding agents in the more practical way. And we offer more courses. These are more oriented to businesses. And we also offer these packages of courses, but also for businesses that cover a subset of these courses for the teams to be a little bit more informed. And that's it. I mean, thank you very much, and we can now maybe start answering some questions that you might have.
Yeah. So, Frederico, we have one at least, which is
Okay.
I'm only using the Cloud's API. Can I also define skills and add context to memory?
I don't think that through the API itself you can do that. I'm actually not sure. I'm not aware that you can do it through the API, actually. I think you would have to have like Cloud Code or even Cloud Desktop to have access to those skills. But I would like to check that actually.
Okay. So far is the only question we have. Feel free to add any Q&A for the ones that are still here. And we could answer to your questions. Okay.
Yeah.
So people are asking for the URL for recording. We'll share in an email, a follow-up email, the recording. The recording will be also available on our YouTube channel. So just let you know that we will get there as soon as we share by email.
Any more questions? Yeah.
We have another one. I don't know if you are seeing it.
Yeah, I'm seeing it. I just don't understand what the question is. So what time saving AI brings? I think maybe it's it. Okay. I mean, it depends on the complexity of the project, of course. But I mean, if you really use it with confidence and with good practices, you can save time like by at least 3 times the time it would take you to do some task, at least. I mean, that's my personal view, of course. Of course, it will depend on the bureaucracy of the company and the projects that you are working, because it also that normally what takes more time is dealing maybe with with client specifications and requirements. Those things are never going away with these things. But the development part itself, once things are clear, you can really get some fast track of development.
Yeah, you can even share that for us to do a proposal nowadays, we were taking like a long time to build in DAC all the information that we need. And now it's pretty automatic. So we just, instead of waiting like 2 hours to customize the proposal, setting everything, we were able to do that now in 10 minutes. So this is the gains that you gain by doing that.
Mm-hmm. Yeah, I mean, as long as the MCPs or I mean, if you even free APIs, you can have you can have access to those documentation tools. As long as there are some APIs or MCPs, you can use those IBM doors or Code Beamer. So you can check if they have MCPs. I'm not aware exactly if they have MCPs, but as long as they have some kind of API, at least you can start integrating with Cloud, of course. I'll copy that it's if the tests are built by AI, code is built by AI. So the human verification. So this is honestly up to you and the teams, but in the end we are responsible for the things that we build, right? So the thing that I was saying is that I think it's really important for when you are making plans and to really focus on providing the most useful context for the agents for it to automatically build code and tests. But in the end, you should always review the results, of course. So the code review is still very important. It's a way to fix problems that obviously the agent might have looked over because they are not perfect, and also to ensure, let's say, mental alignment between all the members in the team. So this is not magic. So you should still follow the patterns that you normally would follow without the AI agents, because in the end you are responsible for it. But so the human verification is always present.
Okay, I think we are already a bit ahead of time. So I'd like to thank you and by Frederica as well. Thank everyone for the time. So that is what we get from this webinar. I hope you have enjoyed, and we'll share briefly in a few days the recording, and will be available also on YouTube channel. So thank you very much
Thank you very much
for everyone
Thank you.
for joining.
Bye bye.